Our next concept in Unit 2 deals with the weather and climate and how that affects our Earth and ecosystems. What we're going to look at first is the atmosphere and weather patterns. The atmosphere is made up of four main layers. The layer closest to the Earth is the troposphere. Above that we have the stratosphere, then the mesosphere, and the thermosphere. If we look at the gases that make up the atmosphere, as we said when we talked about the nitrogen cycle, nitrogen is the most abundant gas. It makes up 78%. Oxygen is 21%. Argon is 1%. All the other gases make up a very small percentage of the atmosphere. Carbon dioxide is only about 0.01%. Ozone is a very small percentage. Water vapor fluctuates depending on how much evaporation that there has been, but the water cycle keeps that balanced. When solar energy enters the Earth's atmosphere, it's going to heat up the equatorial regions more than the poles. And so when that happens, the air and the water at the equator is much warmer. So that warm air and water is going to travel towards the poles, while the cold air and water at the poles is going to travel back towards the equator. It's this constant struggle for temperature balance that causes weather changes on the Earth. So if we look at this, we've got the warm air at the equator is going to rise because hot air is less dense than cold air, and the cold air from the poles starts to sink. So what happens is when we get that moving air, we get these large wind cells. When two wind cells come together, like the cold air that converges at the equator, that is called convergence, which causes in turn the air to rise and diverges towards the poles. However, it's a little bit more complicated. The air is not going to flow straight from the equator to the pole and back again, because while this is happening, the Earth is also spinning. It creates what we call the Coriolis effect. Now, the equator is moving at about 1,100 kilometers per hour, but the poles aren't going to move because they're spinning about an axis. So what happens, let's say that you are at the North Pole and you're either in an airplane flying to a spot on the equator or you're shooting a guided missile at another country. What's going to happen, you cannot fly straight towards your target because while you are in the air, the Earth is spinning underneath you. So you will actually miss your target if you don't make up for that. So this is the Coriolis deflection. So the same thing is happening to the winds that are not tied down to the Earth's surface. Same thing happens to ocean currents. So they appear to curve. So what happens is in the northern hemisphere, the winds appear to move in a clockwise pattern. In the southern hemisphere, they move counterclockwise. Same thing happens with the ocean currents. So instead of that nice simple diagram where we had the air rising from the equator sinking at the poles, because of the Coriolis effect, and you can see this here, in the northern hemisphere they're going to move in a clockwise direction, southern hemisphere in a counterclockwise direction. So instead of the two wind cells, you can see we've got many more that are occurring. Now, in addition to wind patterns being created because of the unequal heating of the Earth, we're also seeing pressure differences. At the equator, we have more solar energy, that warmer air rises, and what results is low air pressure. As the air rises, it carries any moisture that it has with it, and it's going to create clouds as it cools up in the atmosphere. Now, at the poles, the cold air is more dense, so it's sinking, creating a higher pressure at the surface. So you're not having any moist air rising, so no clouds form. You're going to tend to have sunny, dry conditions. And air is always going to move from high pressure to low pressure because of the density differences. The low air is rising, the high air pressure comes in to take its place. That's what creates wind. So looking at this diagram, we have that warm air that rises, so I have low pressure, and so the higher pressure air is going to move in to take its place. In the northern hemisphere, it's moving clockwise, southern hemisphere counterclockwise. So these two bands of wind right here are called the trade winds. They move towards the equator. Now up here I have the subtropical high. I have high pressure where air is sinking. You can see where these two wind cells converge. And so the high pressure air is going to move in to take the place of the lower pressure air at the next wind cell. And once again, you can see how they all curve because of the Coriolis effect. When we have low pressure, we have more precipitation because you've got that warm air rising. So that's why at the equator we tend to have areas that have much precipitation. Most of our tropical rainforests are located in this area. Now, just above and below the equatorial lows, we have the subtropical highs where the air is sinking. They tend to be dry. Some of the world's largest deserts, like the Sahara, are in the subtropical highs. You've got sinking air, nothing rising to create precipitation. And then you've got your polar lows where you have more precipitation, your polar highs, once again, where you have very little precipitation. Basically, the tundra is a cold desert. In addition to the global winds, we also have jet streams. There's about 5 jet streams, and they move, they're at the upper part of the troposphere. They're in the upper part of the troposphere and the lower part of the stratosphere, and they move from east to west. So there's one right over the United States, and it's going to affect our weather patterns. Whenever you watch a weather report on the news, you see that everything moves from the west coast towards the east. It's also going to affect air travel. If you're flying from North Carolina to California, your flight there is going to be a little bit longer than, say, a flight from California back to North Carolina. Same thing if you're flying up to the northeast coast. All right, so what happens is our pressure centers move from west to east. Now, looking at this weather map, you've probably seen something like this before. The red H's stand for high pressure center, and the red L's stand for low pressure centers. Lows, once again, you're going to have more air rising when you have low pressure, so you have that warm moist air condenses to form clouds. You tend to have more precipitation. One of the things that happens at a low center is that the winds tend to blow inward. At a high pressure center, high pressure keeps the air closer to the ground, so you tend to have clear skies, fair weather, and the winds blow outward. And this is kind of what that looks like, where the high pressure air is descending, it hits the ground and moves outward in a clockwise direction, so your winds would move outward from this pressure center. The low, as it's rising, the air moves towards the center in a counterclockwise direction, so that would affect your wind patterns also. Air masses are large lumps of air that have similar temperature and moisture throughout. And depending on where they are, they might bring in warm air if they are from the south of us, so those are our tropical air masses, or cool air if they're polar air masses from the north. Notice that the ones over the ocean are called maritime and the ones over the land are called continental. Now, anytime you have two air masses that collide, that creates a front. And fronts are usually going to be associated with precipitation because when a cold and warm air mass collide, that warm air, because it's less dense, is going to rise. On a weather map, you usually see symbols such as these to indicate fronts. A cold front is indicated by blue triangles. So we see one of those here. So what that is, this is a cold air mass that's moving into a warm air mass. The ones that are red represent warm front. They're usually half circles, so this warm air mass is moving into a colder air mass. And we'll talk about what occluded and stationary fronts are as well. So warm front, you've got warm air that moves into cooler air. The warm air rises, forms clouds, and usually they're low angle clouds. So you'll see cirrus clouds first, followed by cirrostratus, altostratus, and ultimately nimbostratus, which are precipitation clouds. And you can predict when a warm front is coming if you see this order of clouds arriving.